Hello and welcome everyone to LFI Educates. Today we are going to discuss about chapter 2, units and measurements. Now to understand this chapter, units and measurement, first thing that you'll have to know is about physical quantities or physical quantity. What is a physical quantity? Then you'll say that quantities which are measurable, which we can measure. Those quantities we call them as physical quantity. Like suppose mass we can measure, length we can measure, time we can measure, electric current we can measure. So these quantities will be termed as physical quantity. But the quantities which we cannot measure, as an example, sorrow or pain, we cannot measure these quantities. If two persons they are having pain in their legs due to some injury, then we cannot measure the degree of pain, how much they are getting in their body. We cannot measure them quantitatively. We cannot measure, so they don't come under physical quantities. But the quantities which we can measure, those quantities we call it as physical quantity. Physical quantities are also of two types. The first type is that base quantities we say, or fundamental quantity, and the second one we say as derived quantity. When we talk about fundamental quantity, we mean that the quantities which are independent of other physical quantities, they can exist alone. Those quantities we call them as fundamental quantity. Like suppose say distance, it's a fundamental quantity. Displacement, it is a fundamental quantity. They can be defined individually alone. They are independent of other physical quantities. But when we discuss about derived quantity, then those physical quantity which requires the help of other physical quantities, or which can be defined with the help of other physical quantities. Let us say speed. It is distance traveled per unit time. So to define speed, we require two fundamental quantities or base quantities. You can see distance are taken from here. Time is also fundamental. So I am taking time as well. So with the help of two or more than two physical quantities, if we can describe a physical quantity, then that quantity will be called as derived quantity. Now let us see about the standard physical unit. What does it mean, unit? Unit. When we say unit, a unit is a standard amount of a physical quantity It is a standard amount of a physical quantity that is used to express the magnitude of that physical quantity. So when we talk about unit, or when we discuss about unit, it is a standard amount. It is a standard amount of a physical quantity Now physical quantity may be mass, length, time, distance, speed, anything it may come, that is used to express, and that you need to express the magnitude, the value of that physical quantity. Now if I say 5, then it is just a numeral, but if I put here kg, the unit, if I put it, you come to know about the mass. I am talking about mass, 5 kg. So it expresses the magnitude of that physical quantity. The physical quantity is mass. It gives us the magnitude as well, the value. If I simply write kg, then you know that it is, I am talking about 1 kg. It gives us the magnitude, the value of that physical quantity as well. Now writing writing unit, it also gives us an idea about the particular physical quantity. Like suppose say I am writing 10 degrees Celsius, then at that moment you know that I am talking about temperature of a substance. The unit tells us, this unit tells us what physical quantity we are measuring as well. So these are called units, like speed. When I say speed, then I write some numerical value first of all, say 7, and meter per second. The SI unit of speed is meter per second. Then this represents the unit, and as a whole it represents the physical quantity called speed. Now when we discuss about unit, here also we classify them into two types. One is called fundamental unit and the other one is called derived unit. Fundamental unit, fundamental, or we call it as base unit, and the other one we call it as derived unit. Now when we talk about fundamental or base unit, it is that unit which can exist independently without the support of any other physical quantity. Like suppose fundamental quantities, you know, mass, length, time, they are called fundamental or the base quantities. Their units will be called as base units or fundamental units. Suppose say for mass it is kg, kilogram, length it is meter, time it is second. So they don't take the help of any other physical quantities or any other units. They can exist independently. Those units we call them as fundamental or base units. But when we talk about derived units, then in derived units, the units will be derived by taking the help of other base units that you can see here. As an example, I will say about speed. Speed, as you know, it is distance divided by time. Distance, if I write in meter, time in second, you can see that I have taken two units, meter and second. Here, meter is taken from length and second is taken from time. So this type of units we call it as derived units. Another example, acceleration. We write meter per second square. Sometimes 2 or more than 2 also it can be. When we take 2 or more than 2 units from the base or from the base unit, then that unit is termed as derived unit. Suppose it's an example, area. Area will represent with meter square. We are using same unit, base unit, but we are using 2 times. So when we use 2 times or more than 2, suppose say volume. Volume we write as meter cube. Meter into meter into meter. 3 times I have taken. So in that case, the units will be called as derived unit. For length, mass and time. For these three base quantities, they were using FPS system, or we call it as British system also. In this, length was taken as foot, F is for foot. The second one, that is pound, P is for pound. That was used for the measurement of mass. And S, that is second, that was used for the measurement of time. The second unit they were using was CGS system, in which the length was measured in centimeter, mass was measured in gram, and time was measured in second. Then the third system that were being used in olden days was Cgs system. In Cgs system, length was measured in meters, mass was measured in kilogram, and time was measured in second. So these are the three different systems that were being used. The first letter that you are looking here, F, C, M, these are for length. Second one is for mass, and the third, that is S, you can see it is for time respectively. But in the year 1971, the General Conference of Weights and Measures decided to avoid this confusion of using different system of measurement. They wanted to unify together the whole world to use, whether it may be commercial or scientific or industrial or for domestic works, whatever it is to be used, there should be a certain system of measurement which will be common to everyone. That system of unit, we call it as SI system. We call it as SI system. In this system, they rationalized this MKS system, that is meter, kilogram and second, as well as they took another 4 more physical quantities, base quantities. I'll write down here. The physical quantities taken in SI system are mass, length, time, electric current, luminous intensity, amount of substance, and temperature. These are the 7 base quantities they took, and the units that are to be used internationally are mass, kilogram, length, meter, time, second, electric current, ampere, luminous intensity, candela, of substance mole, and temperature is taken as Kelvin, and they are abbreviated as kilogram as kg, meter as m, second as s, ampere as capital A, candela as CAD, mole as MOL, mole, and then Kelvin as K. These are the abbreviations that are to be used while dealing with physical quantities nowadays. This SI system, full form is System International in French, and in English we take it as System International. We pronounce it as System International or International System of Units. Now, these are the physical quantities, 7 physical quantities. Now, 2 more sub-quantities are taken. They are plane angle. Plane angle. SI unit is radian, and the second one is your solid angle. Solid angle we measure as stadian. STERADI, stadian. Now when you say plane angle, you can take a circle first of all. You can take an arc. Suppose AB is the arc. This is the center of the circle. If you join AO and OB, you get an angle. This angle we call it as plane angle. This is the arc length AB and OB is the radius R. So this theta, it is defined as, the plane angle is defined as the angle between the arc length AB divided by the radius, that is R. This gives us the measurement of plane angle. Angle equal arc length divided by radius. And when you talk about solid angle, it is 3-dimensional. You have to take a sphere, a solid sphere. If you take a sphere, a solid sphere, and then cut an arc here, or you cut the sphere in this form, then the angle which will be formed will be called as solid angle, but it won't look like this in plane. It looks somewhat similar to this. If I make it this way, this is a part of the sphere. One part you have cut it, and then here a solid angle will be formed. Here. This angle will be called as solid angle. We write it as d omega, or sometimes we write it as omega. Omega is equal to, is defined as this area of the surface, let us take it as A, divided by the radius square. This distance will be called as the radius of the sphere. Radius square will give us the solid angle, and then the unit, SI unit is radian, and for plane angle the SI unit is radian here. Now let us see what is measurement. Measurement of a physical quantity, I'll write down here. Is the process of comparing a physical quantity with a standard amount of a physical quantity of the same kind So when you compare a physical quantity with a standard amount of a physical quantity of the same kind, it is just a comparison of one quantity with the other quantity of the same kind with the same unit. Like kg, mass you can compare, length you can compare, temperature you can compare. We can compare temperature and mass. So when you say measurement, it is just a comparison with one another of the same physical quantity of the same kind. Then the same kind means we come to know from its unit. If they have the same unit, then we can compare them with each other. To express the measurement of a physical quantity, we need to know two things. The first thing is the numerical value, and the second thing that you have to know is the unit. So mathematically we write like this: Q. If Q represents a physical quantity, then NU. N indicates the numerical value and U indicates the unit that is used to measure. Here Q is the physical quantity, N indicates the numerical value, and U indicates the unit used. It is the unit that is used to measure the physical quantity. So this is all about your topic name, units and measurement. From next class we will be starting our measurements. Thank you and have a nice day. See you soon in LFI Educates.